Double touch method. Place a steel bar to be magnetized on 2 bar magnets as shown here. Now place opposite poles of 2 strong magnets at the middle of the steel bar as shown here. Move the magnets towards the opposite ends of the specimen, keeping the magnets inclined. On reaching the opposite ends, lift the magnets and place them back to their respective original positions. Repeat the process. The polarities developed at the ends are opposite to the polarity of the pole used for magnetization. Place some iron nails on the table. Now bring the steel bar near the iron nails. The steel bar attracts the nail, showing that it has acquired magnetism. Introduction. Magnetization is the process by which a magnetic substance attains magnetism temporarily or permanently. The methods used to magnetize a magnetic substance are single touch method, double touch method, electrical method of magnetization. Demagnetization is the process of removing the magnetic property of a magnet. The magnetism of a magnet can be totally or partially destroyed in the following ways: by rough handling, by heating, by induction, by passing electricity. Single touch method. Place a soft iron piece AB to be magnetized on a table. Take a bar magnet and place one of its poles on the soft iron piece as shown here. Stroke the soft iron piece with the bar magnet. When the magnet reaches B, lift it and place it back to the position A and repeat the process several times. The upper side of the soft iron gets magnetized. Now turn the soft iron bar as shown here and magnetize the lower side in the same manner. The point A will get the same polarity as the pole of the magnet touching it, and the other end of the bar will attain the polarity opposite to that of the magnetizing pole. Test for magnetism. Place some iron nails on the table. Now bring the soft iron piece near the iron nails. The soft iron piece attracts the nails, showing that magnetism is induced in it. Double touch method. Place a steel bar to be magnetized on 2 bar magnets as shown here. Now place opposite poles of 2 strong magnets at the middle of the steel bar as shown here. Move the magnets towards the opposite ends of the specimen, keeping the magnets inclined. On reaching the opposite ends, lift the magnets and place them back to their respective original positions. Repeat the process. The polarities developed at the ends are opposite to the polarity of the pole used for magnetization. Place some iron nails on the table. Now bring the steel bar near the iron nails. The steel bar attracts the nail, showing that it has acquired magnetism. Electrical method of magnetization. The given bar that is to be magnetized is placed inside a long coil of insulated copper wire. The copper wire is connected to a source of direct current as shown here. When the circuit is closed, a strong direct current passes through the coil of the insulated copper wire and the bar becomes a magnet. The polarity of the rod depends upon the direction of the current. If the bar is viewed from one end and the current is found to be flowing in a clockwise direction, then that end will attain south polarity. If the current appears to be flowing in an anti-clockwise direction, then that end attains north polarity. If it is a steel bar, it becomes a permanent magnet. If the bar is a soft iron bar, then it becomes a strong bar magnet and is called an electromagnet. This electromagnet ceases to be a magnet as soon as the current is stopped. Methods of demagnetization. The magnetic property of a magnet can be totally or partially destroyed by rough handling, by heating, by induction, or by passing electricity. Click on each method for more information. Hammering, dropping, and rough handling of the magnet can demagnetize the magnet. A magnet loses its magnetism if it is heated above a certain temperature called its Curie point. The Curie point for iron is 770 degrees Celsius, and that of steel is 880 degrees Celsius. The Curie point for nickel is 358 degrees Celsius, and that for cobalt is 1121 degrees Celsius. If two magnets are placed side by side with similar poles together, each induces opposite polarity in the other. As a result, the magnets lose magnetism. To avoid this self-demagnetization, the magnets are placed in pairs, side by side with their unlike poles together, as shown here. By passing electricity, place the given bar that has to be demagnetized inside a long coil of insulated copper wire in the east-west direction. Connect the copper wire to a source of alternating current as shown here. Switch on the circuit. Now slowly reduce the current to 0. The magnet loses its magnetism as alternating current changes direction continuously. This change in direction of current disturbs the alignment of molecular magnets, resulting in demagnetization.